NASA's Voyager 1 has wowed people worldwide as the farthest human-made thing from Earth. Since it launched, Voyager 1 has been beaming back important info from the edge of space, teaching us a lot more about the universe. But lately the probe sent some weird signals, leaving scientists scratching their heads. These strange signals have sparked lots of discussion, with people wondering if it's just a technical glitch or maybe even signs of something bigger, like aliens. Let's check out these mysterious messages and think about what could be hiding way out in space. Humans have always been curious, and that's what pushes us to explore space. This curiosity set the stage for cool missions like Pioneer 10 and 11, which were big deals back in the day. Voyager 2 took off from NASA's Kennedy Space Center on August 20th, 1977, kicking off a cool time for space trips. Not long after, on September 5th, 1977, Voyager 1 launched, starting a trip that would take it past the outer planets and change what scientists thought they knew. Each spacecraft, weighing about 721 kilograms like a small car, went its own way at different speeds. On December 15th, 1977, something cool happened. Voyager 1 went farther than its twin because of its path. From then on, Voyager 1 became super important for learning more about space, making cool finds that have changed how we see things. Before we get into its recent finds, let's look back at some of Voyager 1's big wins early on. In 1979, when it was about 265 million kilometers from Earth, the spacecraft snapped great pictures of Jupiter. By January of that year, it had done a solid 100 hours of watching, making a time-lapse video showing Jupiter spinning. These 3,750 photos gave us awesome views of the planet's crazy atmosphere and patterns. During this mission, Voyager 1 spotted a ring around Jupiter that we didn't know about and found 2 new moons, which was awesome for learning about the planet. To stay on track and not crash into Titan, one of Saturn's moons, the spacecraft made some adjustments. Then the focus moved past the solar system's planets as the probe headed into interstellar space, going super fast at 325 million kilometers a year. In January 1990, Voyager 1 started checking out interstellar space, pushing past the edge of our solar system. During this time, it did some amazing things like finding 4 more moons, Mimes, Enceladus, Tus, and Rhea, and taking some famous shots of the solar system's far-off spots. On February 14, 1990, from about 6 billion kilometers away from the Sun, Voyager 1 took the family photo, a bunch of pictures showing the inner planets. These 60 images were added to the probe's collection, which already had hundreds of photos from its trips by gas giants. Meanwhile, Voyager 2 did some awesome things too. It clocked wind speeds on Neptune at over 2,100 kilometers an hour. That's about 1,300 meters per second, which is the fastest wind ever seen in the solar system. It also checked out Triton, Neptune's biggest moon, where it's super cold at minus 391 degrees Fahrenheit, making it one of the chilliest places we know. Triton had icy geysers shooting out nitrogen gas and frozen stuff up to 5 kilometers high, showing that it's a pretty lively place. These awesome finds gave us way more info about the different and wild conditions way out in the solar system. Voyager 1 and 2 have really changed our view, showing us that moons we thought were boring actually have stuff going on. This made us rethink our old ideas about their geology. Voyager 2 is the only spacecraft ever to visit Uranus and Neptune up close, which is a record. NASA kept these old missions going by doing smart stuff, like turning off things that weren't needed to save power. The mission should keep rolling until 2030, which will be the end of a great time for the people who've spent their lives working on it. The way Voyager 1 and 2 were made was cutting edge. They were built to spin slowly, so the pictures wouldn't be blurry while they moved. Even before they got to the outer planets, the spacecraft started sending back detailed photos of Jupiter, showing swirling clouds and the big Great Red Spot, a storm that scientists have been curious about for ages. One super cool find was spotting active volcanoes on Io, one of Jupiter's moons. The spacecraft's tools picked up weird readings, which were later backed up by pictures showing giant volcanic plumes and a landscape changed by eruptions. One eruption was found to be 1,000 times stronger than the Mount St. Helens blast, covering an area about the size of France. As the probes kept going, they were slowly powered down to save energy for going into interstellar space. Fun fact, They didn't take pictures of Mercury or Mars because of technical stuff. NASA later launched more missions like Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 passed Pioneer 11 as the probe farthest from Earth. Still, Voyager 1 kept going, and after 14 more years officially entered interstellar space on August 25, 2012. A big reason these missions worked was using gravity assist moves, which slingshot the spacecraft toward their destinations while saving fuel. Instead of just using engines, they used the gravity of planets to speed up and change direction. This let them travel crazy far with very little fuel. As Voyager 1 got close to Jupiter, its gravity boosted the spacecraft's speed. Precise math was key to avoiding any mess-ups in direction or speed. These gravity assists let the spacecraft zoom around the solar system like pros. Voyager 2 also used gravity from Jupiter and Saturn to reach Uranus and Neptune, showing how well this works. Thinking about these awesome missions, scientists can't wait to get more info from the weird signals Voyager 1 has picked up lately. The probes keep exploring beyond the solar system, grabbing data from the edges of planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse images caught 10 eruptions on Jupiter, found more moons, and spotted a ring around the planet that we didn't know about. These finds really boosted our knowledge of the Jupiter system. Voyager 1 also found 4 more moons of Saturn, Memes, Enceladus, Tus, and Rhea, and sent back awesome pictures of the planet and its rings, giving us new looks at what they're made of. Its flybys of Uranus and Neptune gave us important info about their atmospheres and moons and proved how we see the solar system's far-off places. After finishing up their planetary missions, the probes headed for interstellar space, where they keep gathering important science info. This ongoing work grows our view of what's beyond our solar neighborhood. As we wait for more news on Voyager 1's strange signals and what they could mean for our view of space, the inspiring trips of these spacecraft keep amazing scientists and space fans alike. Their work is still super important for growing human knowledge and pushing the limits of space science. The Voyager missions have given us cool views of the solar system and beyond, making iconic images and amazing data. Besides their science work, the spacecraft carry something to share Earth's story with any smart beings that might find them. The Golden Record has greetings in 55 languages, music from all over the world, and natural sounds like rain and whale songs. This interstellar time capsule shows that humans hope that smart life out there might one day find it and get what it's all about. Voyager 1 and 2 had a bunch of science tools that changed how we see space. These included magnetic field detectors, plasma wave analyzers, and imaging stuff, all of which gave us key info about space conditions. The magnetometers helped show the magnetic fields of the outer planets and how they relate to their surroundings. Plasma sensors helped explain how solar wind affects planetary atmospheres. One of the mission's biggest wins was mapping the edge of the heliosphere, which is a region full of solar particles and magnetic forces that surrounds our solar system. As Voyager 1 got close to this boundary, it picked up a change from solar particles to interstellar stuff, giving us important data about how this boundary protects Earth from nasty cosmic rays. The spacecraft found a spot called the termination shock where the solar wind slows down and gets thicker. Beyond this is the heliosheath, a wild zone where solar and interstellar particles crash into each other, making a busy and lively place. Voyager 2's trip added even more to what we know about the solar system's edges. Its observations, especially of Uranus's magnetic field, which was tilted in weird ways, challenged old models, and got people looking into planetary magnetism in new ways. These missions didn't just boost science knowledge, but also sparked the public's imagination. The great images of distant planets and the cool stories of the spacecraft have inspired people for years. Famous photos of Saturn's rings and Jupiter's Great Red Spot are still some of the most memorable images in space trips. NASA has been keeping these missions alive by doing smart things like turning off systems that aren't needed to save power. The mission should last until 2030, which will be the end of an era for the teams who worked on it. The way Voyager 1 and 2 were designed was really innovative. They were made to spin slowly so that the pictures wouldn't be blurry. Before they even got to the outer planets, the spacecraft started sharing great pictures of Jupiter, showing swirling clouds and a huge Great Red Spot. a storm that scientists have been wondering about for ages. One of the coolest finds was spotting active volcanoes on Io, one of Jupiter's moons. The instruments picked up weird readings, and then the images showed huge volcanic plumes in a landscape that was changed by eruptions. One of these eruptions was 1,000 times bigger than the Mount St. Helens explosion, covering an area about the size of France. As the probes kept going, they were slowly powered down to save energy for their trip through interstellar space. They didn't take pictures of Mercury or Mars because of technical reasons. NASA later sent out other important missions including Pioneer 10, Pioneer 11, and New Horizons. Pioneer 10 passed Pioneer 11 as the probe farthest from Earth on February 17, 1998. Then Voyager 1 kept going, and after 14 more years, it officially went into interstellar space on August 25, 2012. A big part of why these missions worked was how they used gravity to help them along. They used the gravity of planets to slingshot them toward their targets, saving fuel. Instead of just using their own power, they used gravity to speed up and turn. This meant they could cover huge distances without using a lot of fuel. When Voyager 1 got close to Jupiter, Jupiter's gravity made it go faster. It was important to be really careful with the math to avoid risky changes in speed or direction. These gravity assists helped the spacecraft move around the solar system without any problems. Voyager 2 used gravity from Jupiter and Saturn to get to Uranus and Neptune, which showed that this method really works. Thinking about these missions, scientists are excited to see what information they can get from the strange signals that Voyager 1 has been sending. The probes are still exploring beyond the solar system, gathering information from around planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse images showed 10 eruptions on Jupiter, spotted new moons, and found a ring around the planet that we didn't know about. These discoveries really added to what we know about Jupiter. Voyager 1 also found 4 new moons of Saturn's, Memes, Enceladus, Teus, and Rhea, and sent back great pictures of the planet and its rings, giving us new details about what they're made of. Its flybys of Uranus and Neptune gave us important info about their atmospheres and moons, making our view of the far-off parts of the solar system much better. After the planetary missions, the probes headed for interstellar space, where they're still collecting valuable scientific information. This work keeps growing our view of what's out there beyond our solar system. Here, as we wait for more updates on Voyager 1's weird signals and what they might mean for how we understand the universe, the inspiring trips of these spacecraft keep capturing the attention of scientists and space fans. Their achievements are vital for pushing human knowledge forward. The Voyager missions gave us awesome views of the solar system and beyond, creating famous images and important information. The spacecraft have a cultural item with them that's meant to share Earth's story with any smart beings they might run into. The Golden Record has greetings in 55 languages, music from around the globe, and natural sounds like rain and whale calls. This space-time capsule shows humanity's hope that smart life in outer space might find it someday. Voyager 1 and 2 had a lot of cool science gear that changed how we understand space. They had magnetic field detectors, plasma wave analyzers, and cameras, all giving important insight into space environments. Magnetometers helped show the magnetic fields of the outer planets and how they interact with what's around them. Plasma sensors helped explain how solar wind has an effect on planetary atmospheres. One of the mission's biggest wins was mapping the edge of the heliosphere, a region filled with solar particles and magnetic forces that surround our solar system. When Voyager 1 got close to this border, it noticed a change from solar particles to interstellar stuff, which gave us key info about how this border protects Earth from risky cosmic rays. The spacecraft found a point called the termination shock, where the solar wind slows down. Beyond that is the heliosheath, a wild area where solar and interstellar particles bump into each other, making a rich environment. Voyager 2's trip added more to our knowledge of the solar system's edges. The observations, mainly of Uranus's magnetic field, it was tilted at weird angles, went against existing ideas, and sparked scientists to look more into planetary magnetism. These missions didn't just grow scientific understanding. They also sparked the public's imagination too. The amazing images of far-off planets and the great stories of the spacecraft have been a motivation for many years. Photos of Saturn's rings and Jupiter's Great Red Spot are some of the most remembered pictures of space ever.